Okay, so we're doing this integration by tables. So our first challenge is, can you identify which formula is going to match that? So, and when you do this on your homework, on your test, I want you to tell me which number you think it is. And so because we got to agree on that first of all.
Let's do this now. So is A just representing any constant?
Yeah, A is any constant.
Okay. So 84.
Good. Yeah. So then we're going to write 84. So that is the correct formula. Now in 84, we're going to have to say what is the u.
Negative x squared.
Okay, and so then we need to also know what the du is. So that's going to be a negative 2x dx. So our formula is that we're going to get du over 1 plus e to the u. So we have our 1 plus e to the u. Our du has an extra negative 2 in it, right? So we're going to have to then, so our dx is going to be this du over negative 2x. So we're going to get an extra negative 1/2. That's not part of the formula. We okay with that?
Oh, yeah.
Then, so we're going to get then, we're going to go negative 1/2, and then we're going to write to our formula answer. And so that is going to be, this is where you get to like it.
So negative x squared minus the natural log of the 1 minus x squared, or 1 plus e to the negative x squared.
Good.
Plus e.
Got it. Okay? Make sense? Okay. Now we're going to talk also about what are called reduction formulas. So what we mean by reduction formulas is several formulas in the tables have a form integral of f of x dx is going to be some, and they get kind of a partial answer, and then they will give you a new integral. Kind of like what we see in integration by parts, very much like that. So these are called reduction formulas because they're trying to reduce it. They're trying to reduce one integral into something a little easier. It's trying to reduce the integral to the sum of the function and hopefully an easier integral. So when we face these, then I would expect you to, tell me on the first one, what's the number of the formula you used. And then when you get to the next one, we're still doing the tables. So then you may get a different formula for the second one. So for example, let me get some space here. You okay to there? Okay. So let's see if we can do the integral of x cubed sine x dx. So can you first find which, what's that?
54.
We gotta find where I put it on here. Yes, 54, okay. And so on 54, what are we gonna call the u? Good.
And n equals 3.
And n is equal to 3, good. So you'll have to say all this so I can follow what you're doing. Okay, so then we get, what?
So you get negative x cubed cosine of x plus
Negative, is it x cubed or x squared?
it just says negative un, so it should be x cubed. N is 3.
Okay, negative x cubed, and then what do we have next?
Cosine of x
Cosine x,
plus 3 integral
good,
of x squared.
okay,
Cosine of x.
good.
And then for the next one, we go to 55.
And for 55, we've got,
We've got u equals x and n equals 2, so we get
okay,
so we get x squared sine of x
I'm gonna keep this along, so then we've got x squared, sine of x,
minus 2 integral of x sine of x.
okay.
And then we go to 52. Right?
You got the angle, good. And so,
So that would become just sine x minus x cosine x.
say, what was it again?
Sine x
Yep.
minus x cosine x. But that's all divided by 2. So 2 sine x minus 2x cosine x.
Okay, so 2 sine x,
Plus 2x cosine x. Plus 8.
okay, now be careful though, because remember this had the 3 on it
Yeah, I forgot about that.
from back there. And then we still have the negative x cubed cosine x. So at the end of the day, we're gonna get our negative x cubed cosine x. And
That should be plus 3.
that should be here, so that should be, that 3 is gonna multiply actually all of this stuff. Okay, so then we get the 3x squared sine x, and then that's gonna make that be a 6
Yeah.
sine x and a 6x cosine x. Okay, very good.
But isn't it minus 2?
Let's see.
So would it be a negative 6?
Yep. So that is gonna be a minus here. And that was supposed to be a minus here, right? So we go to
Yes.
plus there.
Yep.
Okay, good to go? All right, let me jump to rational functions of sine and cosine. So when we have something like, say, an integral of sine 2x over x plus cosine x, then the first thing we want to do, and this is where our, that formula sheet, that we don't like these being different angles, but we have an identity for sine 2x. So we'll
Then
do
we
that
will
first.
Sine 2 sine x cosine x. Yeah.
Good. Now, so once we've done that part, now, first you're going to look for the forms that involve sine and cosine. If you can't find anything that's going to work, and I don't think you will on this one, then we want to like make a u substitution and then see if what we're left with doesn't fit like an algebraic form. So what would we choose as our u in this case? Do you suppose?
The x plus cosine x?
Just the cosine.
Just the cosine.
Yeah. So the du okay, so let's see what we can do. We have 2 sine x, that's going to be a u, du over a negative sine x. Oh, that was supposed to be a 2, not an x, sorry.
Oh, okay.
Otherwise we're going to be in trouble.
Okay, then, yeah, we have 2.
Can you find one for that?
Yeah, there's 3 in there.
Yep, so we got number 3. And for number 3,
U equals u, or currently u equals cosine x, so it should be cosine x.
let's just call it u for now, and we'll go back after we finish that up. We also need to know what is the a.
Yeah, so a is 2, b is 1.
And b is 1.
So we should get 1 over 1 squared, so 1 on the outside.
So, oh, I lost a negative here. That should have been a negative 2. So negative 2, and then what was it again?
So 1 over 1, because b squared is 1. And then the parentheses 1 times u, it's just u minus 2 natural log of 2 plus u. Absolute value of the natural log.
Good.
Or the natural log of the absolute value, sorry.
Good.
And then it's plus
And then we go back to our, what we called u was our cosine x.
So cosine x minus 2 natural log. But yeah, absolute value is 2 plus cosine x plus.
Good, good. Okay. All right, so far.
Good.
Now, there's one more crazy substitution that we can kind of resort to if nothing else works. So we can't find anything that's a match on the formula sheet, and we can't make like a u substitution with a trig function that's going to work. Then we have kind of our last resort. There's a special substitution. And this is on your sheet, I believe, on the table at the very, very end. Special substitution to convert a trig expression to a standard rational expression. So this was kind of like the reverse of what we do in trig substitution. You know, we see an integral, we don't know how to do it, so we convert it into trig functions, and we get an integral with trig trig functions that we can do. We do that integral, and then we go back to our triangle and go from the trig functions back to the algebraic. This is going to go reverse. Okay, so if what we're going to do, this comes from, we're going to say u is equal to, so this is for, let me say for sine and cosine. So this is a substitution for sine and cosine. So if you have an integral and it's got sines and cosines and you can't figure out anything that's going to work, then what we're going to do is say u, so where this comes from, what we're actually going to say, well, I'll show you the substitution and I'll show you where it comes from. We're going to say cosine of x is going to be 1 minus u squared over 1 plus u squared. Sine x we're going to replace by 2u over 1 plus u squared. And the dx is going to be 2 du over 1 plus u squared. So we had an integral, it's got sines and cosines in it, we can't figure out what to do, it's not a match, we tried doing whatever clever substitution we can, we can't get it to resolve. This is kind of our method of last resort.
Where does the u come from?
So
How do we find the u?
let me show you where, I'll show you where it comes from, then we'll do an example of it. So where this comes from actually is we're going to say that u is actually sine x over 1 plus cosine x. And that comes from actually half angle formula for the tangent of x over 2. So in a sense, we're saying u is equal to tangent of x over 2. And then we're going to say that we know tangent of x over 2 from a half angle identity is equal to sine x over 1 plus cosine x. So if we look at this for a moment, then I'm going to solve for cosine x and come up with that, and solve for sine x and come up with that. Take the derivative of this and come up with that.
Using the u equals.
Just, yeah, so starting with this. So this is our actual substitution. In practice, what we're going to do is we're going to say, we have this integral that's got sines and cosines, we can't get it. Every cosine we're going to replace by this. Every sine we're going to replace by this. And the dx we're going to replace by that.
Okay.
And then hopefully that integral we can actually do something with.
And then at the end, when we plug in the u equals sine x, so 1 plus cosine x, always.
So then, yeah, then once we have the integral, then we can go back and plug in that or that. Here, let's do that. So I can show you this another time because let me do an example because I think that's the part that we want to be able to take away. And then I go through it on that video if you want to see why it works the way it does. What you need to be able to do is to be able to use it. So let's do the integral from 0 to pi over 2 of 1 over, and we'll say 1 plus sine theta plus cosine theta d theta. So they're pretty distinctive integrals like this when you have to do something unusual like this substitution. So it won't take you very long to look at the trig integrals and say, it doesn't fit any of those. And there's not really any great substitution we can do. You can't, if you say u is cosine theta, du is sine theta, it's not going to lead to anything.
Right.
So it's not like you're going to do this very often. They're pretty distinctive. So now we're going to make our substitution. So we're going to say the d theta is going to be our 2 du over 1 plus u squared. Is that okay?
Oh, yeah. It's yeah.
Then in the denominator, we're going to get our 1 plus the sine theta is going to be 2u over 1 plus u squared. And the cosine theta, and this is on your sheet,
Yeah.
is going to be the 1 minus u squared over 1 plus u squared.
And then do we turn the 1 into 1
Uh,
plus u squared over 1 plus u squared to cancel them?
Yeah, that's exactly right. So we can change this into 1 plus u squared over 1 plus u squared. And you can see everything's got the same denominator. So however you want to think of that, I would think of it as multiplying top and bottom by that 1 plus u squared, that 1. Is that okay?
Yeah.
So then we're going to get our integral is going to be just 2 du in the numerator. And then we're going to get, looks like 1 plus u squared plus 2u plus 1 minus u squared, all in the denominator.
Yep.
Does that look okay?
And then
So that's going to be
the 2.
2 du over 2u plus 2, is that
Yep.
look right?
And du over 1 plus u can equal to
Yep, so 1 over u plus 1. I think we can just go right to this. So that's going to be what?
So du over 1 plus sine x over 1 plus
Let's do the integral first, then we'll go back.
Oh, okay, that makes more sense. So, number 3, or we could just do it.
Yeah, we can go, what's number 3 say?
Number 3 is u over, no, we don't have u. So we don't need it. So should it, log of u plus 1?
Yeah, it's just a log of u plus 1. And then we go back to our, and actually we're going to make it a definite integral here. So our u was the cosine of theta, is that right?
I thought the u was the one that's.
Oh, I'm sorry, you're right, tangent. It was the, yeah, u is really the tangent of x over 2. And we're going to evaluate that from 0 to pi over 2. Which is going to be a problem. Pi over 4 is okay, because tangent pi over 4 is, yeah, I'm going to put that in the logarithm.
Log of 1 minus log of 0.
What's the log of 0 though?
No,
That's
that's
a
fine.
problem.
Yeah, I'm fine.
Yes.
We require assistance in the problem.
Okay.
Which problem is it?